Okay, a balloon rises at the rate of 8 feet per second from a point on the ground 60 feet from an observer. Find the rate of change of the angle of elevation when the balloon is 25 feet above the ground. All right, so this time we're trying to find the rate in which an angle changes, like instead of a length. And you'll notice like the 60 is already labeled on the picture here. And that's going to be one of those values that is not going to change. Of course, as this balloon continues to rise, of course, the vertical distance here is going to constantly change. But then as this balloon rises, like for instance, if it gets up here where I've got my finger, and you were to get the measurement of the angle, that angle is going to be larger as well. So as it goes up, the vertical side changes. Of course, the length of this hypotenuse changes, even though that's not even going to be anything we're going to refer to, but it does change, but the angle of elevation also changes. But the distance from the balloon to this observer is not going to change as the balloon goes up. So that's one of those values that's going to be constant regardless. Okay, so let's identify what we got to find, what we've been given. All right, so a balloon rises at a rate of 8 feet per second. So that would be this distance from here to here that's changing. And you can call that whatever variable you choose to call it. I'm just going to call it x. So that's going to be, the rate would be dx dt. Okay, now you're specifically going to look for this when the balloon is 25 feet above the ground. So when does this distance from here to the balloon exactly reach 25 feet? So another piece of given information that I'm going to use is going to be the 25 feet. All right, what am I trying to find? Now I'm trying to find the rate in which this angle is changing. So the variable that's being used here for that is theta. So you would refer to that rate as d theta dt. Okay, now with your equation, since we're talking about the rate in which an angle is changing, this is going to involve using your trig functions and just going back and using opposite, adjacent, and hypotenuse. So from the angle that we're trying to get the rate of course, I do have a value of 25. Like, what is going to be this angle of elevation when this vertical distance reaches exactly 25? And of course, I have this distance here, the 60. So this would be the opposite. This would be the adjacent. So the equation that I'm going to look for is going to involve tangent because tangent of this angle would be equal to x over 60, opposite over adjacent, okay? Now, do our differentiation. So the derivative of tangent is secant squared. And then you have to apply your chain rule, remember, and take the derivative of the argument, but the derivative of theta would just be 1 d theta dt. Now, with the x divided by 60, what I want you to do is just think of that as if this were just 1/60th x, okay? So 1/60th would just be a constant multiple here. So when you take the derivative, then you would just have 1/60th dx dt. Okay, so let's look at everything that we've got here. Of course, we were given dx dt. That's going to be the 8. I actually don't have just x in here to put the 25. I am going to need to use it in a little bit. I don't have theta. So I need to have something to substitute. Sometimes it may be that you directly substitute in for theta. Sometimes you're going to substitute in for the secant theta. Of course, I'm trying to find d theta dt. So this is what I've got to work on right here, is this secant squared theta. All right, what you're going to want to do is actually find the third side here, your hypotenuse. Like, what are all the numbers when this vertical side reaches exactly 25, okay? So using my Pythagorean theorem, I would have 25 squared plus 60 squared is equal to, and we'll just call that side y. I'll just label that as y. Okay, so that's going to give me 25 squared plus 60 squared is going to give me 4,225. So that would be 65. Now, of course, I know taking square root of both sides plus minus, but you're talking about the length of one of the sides of a right triangle, so that would not be a negative value, just the positive 65. Now, from this, let's come up with secant theta. Now, if you remember, secant is going to be hypotenuse over adjacent, okay? So from this angle, of course, the hypotenuse is what we just found, that's the 65, and the adjacent is the 60. And that's going to end up reducing to be 13 over 12, okay? So I have a value that I can substitute for the secant theta. Like I said, that's what we were needing to do, a little extra work to come up with. Now, whatever I plug in for secant theta, I do have to square it. So that's going to be 13/12 squared. Of course, I'm trying to find d theta dt. And that's equal to 1/60th times the 8. So now we just need to work on getting d theta dt on one side by itself. So this is 169 over 144. Okay, and if you wanted to reduce, of course, this is 8 over 60. It's going to reduce to be 2 over 15. And then you're going to need to multiply both sides by the reciprocal here. So d theta dt would be equal to, that's going to end up reducing to be 96 over 845. And your units on this, since you're talking about an angle, of course, when you're talking about the measurement of an angle, it's either radians or degrees, but these are all going to end up working where it's just the way the setup is. You do actually end up with it coming out in radians and not in degrees. And of course, this would be radians per second because, like, you know, I had the feet per second back up there at the top. So this is the answer that we were looking for.